The ACER M200A monitor, released in 2010, this 20-inch, wide-ish monitor came packed with a lot of features for $159. As with most people in this day and age, my roommate can't afford a replacement, so I offered to try to repair it. My roommate let me take hers apart after it stopped powering up. Thinking that it might be bad capacitors, I decided to open it up and have a see. After opening the monitor, there were 3 capacitors with pop tops, a clear sign of failed or failing capacitors. Originally, I was going to replace all the capacitors, but I just ended up replacing the 2 pairs that supplied a step-down DC to the monitor. Now, at this point I must say, don't touch power supplies unless unplugged and the high voltage capacitors have been discharged. You could die. I waited a few days for the main side capacitors to discharge, then confirmed using a grounded screwdriver. Okay? Okay, now to remove the power supply. First, the wire harness to the main board is removed, followed by the upper smaller connector, then the lower one. Next, the 4 mounting screws in the corners, followed by the 2 screws in the AC connector, and the whole board comes off. Here, as you can see, I'm disconnecting the wire harnesses. Then I checked all the screw locations and proceeded with removing the screws with my driver. I opted to use a cordless driver because it makes work way easier, and I'm just a lazy guy who just doesn't want to twist a screwdriver for minutes on end. Use whatever you feel comfortable with, but remember, always be gentle with the screws because you can strip something, so just watch out. Also, if you're using a screwdriver with a magnetic tip, those are a godsend in situations like this. They help keep you from dropping screws down your sock or on the ground. But I did miss the 2 main power connector screws. Here we are again. You can see me using the magnetic tip. I love that. After they were removed, the board came off with no issues. Okay, with the board out, we can get a better view. These 2 capacitors are bad. Here, this one's bad, but the other is good. We'll replace them both anyways. On the back side, I marked the locations of the capacitors that need to be replaced. So, let's get those parts. The package has come. We tear it open to reveal what's inside. Rip. Now, when ordering parts online, always verify to make sure that they are the right form factor. Sometimes you can buy the same part with the same frequencies and voltages, but they'll be different sizes. Now I turn on my soldering iron to its standard 360 to desolder the board and remove the components. Nice and hot now. And now we try to melt the old solder. A little tough to melt. Let's turn it up a bit more. We'll turn it up to 420. Well, what I didn't show is that after desoldering and having a few attempts, I had to crank my soldering iron way up. But after getting it to the highest temperature and using some solder wick to remove the old solder, removing the components was just as easy as could be. I use solder wick because I just don't have the solder sucker, but if you have one of those, use that too. But after all the solder's been removed, the components just fall right off the board. And the holes are nice and cleared and you don't have to worry about anything else. So here they are. All the bad little capacitors are keeping this thing from turning on. There's about $7 worth of components right there. Okay, now we have the circuit board mounted in the vise. The holes are cleared and the capacitors are here. Electrolytic capacitors come polarized. The line on the side denotes the negative pole, followed by the short lead. The side with no marks and the long lead is the positive side. The circuit board print shows which side is negative. You line up the capacitor and just stick it through the holes. These types of components are known as through hole because you put them through the hole. That's pretty much all you need to do. You stick them through the hole, put a little solder on them, make sure they're seated right, and you're good to go. When you're soldering, make sure you have adequate ventilation too, because solder fumes are poisonous. And with the parts installed, we just clip off the extra long leads and they're good to go. Now all we have to do is just repeat for the other side. Sometimes it helps when you install the components to spread the leads out a little bit. That way it keeps them from falling out. These were a little bit smaller and more wobbly, so I spread the leads out so that they were just sit flat a little better. Again, when you're soldering, you usually want to do it in a position that's more conducive to soldering. Pretty much laying the board down and soldering flat on a surface like this. I have the board tilted up so that the camera can see exactly what was going on here. And since this time around my head wasn't in the way, you can too. And just like that, the solder solidifies and we clip off the leads. This time I'm going holding them before I snip them, because when I was snipping them earlier, they were just shooting across my garage. And that's that. Next thing we do is just check to see if the power is flowing through the rails. Okay, I have the board plugged into the wall, and here I'm just testing the power rails to see if I'm getting the proper voltage through them. They are marked on the pins. There's 5 and 12 volts. So here I'm checking the 5s, and I'm coming up at like 5.12 if I remember right. It was really close, so it was looking pretty good. You're not going to get exactly 5.00. You're always going to be a little over, a little under. There's just variance in the capacitors and the resistors and whatnot. Pretty much what this does is that it takes the 110 from the wall and steps it down to a usable DC current, which is then rectified through the diode bridge and then cleaned up through the capacitors and then split off to different power rails through the voltage regulators and whatnot. So you're not getting a full 110 going into the monitor. That'll just blow things up. So this is what this does. And here we are, just getting ready to put everything back together again. So much easier putting things back together than taking them apart. Again, I'm using my trusty electric driver here to get all the screws back in together with that magnetic tip. But yep, everything goes in and everything was screwed down nice and tight. Again, I did have the capacitor discharged here so I wouldn't get shocked. Make sure that you won't get shocked. Always discharge capacitors with a grounded screwdriver. Let me plug in all of our wires. There's pretty much only one way they can go, so you can't cross anything, which is real nice. And before you put the back on, you just got to make sure that it works. So here's a moment of truth. We'll see if it actually turns on. And it kind of got confused where controls were because they're only marked on the back shell, not on the front bezel. Man, my heart stopped here. But then I got the HDMI. And with that, I knew that the monitor was getting power and that it was working fine. Well, I hope you enjoyed that video. This is a new format I was just playing with. Not really a new format, I guess, but using some new software, and I hope you enjoy the video. The purpose of this was to show that a lot of stuff that we own, when it breaks for stupid reasons, and that it's really easy to repair. Then, spend hundreds of dollars to buy a new one. Usually, outside of certain things, if you spend a lot of money to buy a newer equipment, you're not getting much of anything. You might get Wi-Fi connectivity, but that's pretty much it. Overall quality doesn't change. So keep that in mind. If you have a monitor that's burnt out and you want to save a couple bucks and it still gave a good picture, try repairing it. It's just the cost of extra pieces. So yeah, go out, fix things, build stuff, have fun, and I'll see you next time when I make another video. Alright, have a good night.